So the next problem based on standard penetration number. A SPT is conducted in a sand deposit at a depth of 20 meter. The water table is at 8 meter below the ground level and N value is 40. Find the corrected N value. Unit weight of sand above the water table is 80 kN per meter cube and saturated unit weight of sand below the water table is 19 kN per meter cube. Take unit weight of water as 10 kN per meter cube. Okay. So here the condition is like that there is water table and the water table is not at the ground level, it is at 8 meter below the ground level. So above the water table the soil is in in normal condition. Above the water table it is in bulk unit weight, and below the water table it will be saturated one. Okay, so here above the water table unit weight is given as 18. So above the water table means for a depth of 8 meter it is 18 and total depth 20. So the remaining 12 meter depth it is submerged condition. So submerged unit weight is equal to 19 minus 10, that is 9. So for 12 meter depth it is submerged one 9. So altogether effective overburden pressure, there is change in effective overburden pressure. So the equation for two layers. So for 8 meter it is given as 18 kN per meter cube, and for 12 meter, that is below the water table, since it is submerged one, it is submerged unit weight 9. So effective overburden pressure is 252 kN per meter square. So first correction is correction for overburden pressure. So the equation 0.77 log 2000 by Q, and substituting these values, N is 40. So it is 27.7. So it is taken as 27, not 28, because since it is number we have it to approximate to the lower one. So 27.7 means 27. So next correction we have to do dilatancy correction for this 27. Okay, so since it is greater than 15, the equation for dilatancy correction is 15 plus 0.5 into n dash minus 50. So n dash means 27 and the corrected one is 21. So this is the corrected n value after doing overburden pressure correction and dilatancy correction. 21 is the answer. So next problem. So a SPT is conducted in a sand deposit at a depth of 20 meter. The water table is set to 25 meter below ground level. If n value is 40, find the corrected n value. Unit weight of sand above the water table is 18 kN per meter cube and saturated unit weight of sand below the water table is 19 kN per meter cube. Take unit weight of water as 10 kN per meter cube. So here it is given the unit weight of sand above the water table is 18 and below it is 19, but here the water table is far below the ground level, that is we are considering the sand for a depth of 20 meter and water table is at 25 meter the ground level. So we can neglect about this water table, it is not coming in our area. Okay, so effective overburden pressure as calculated as 20 meter depth, it is unit weight of sand above the water table. We are not taking the water table since it is 25 meter below the ground level. So 18 into 20, 360 kN per meter square is the effective overburden pressure. So effective overburden correction equation 0.77 log 2000 by Q, and Q is 360 and N is here 40. So the corrected that is n value after overburden correction is 22.9. So it is rounded as 22. So it is the corrected n value. And here as the water table is below the SPT depth, that is SPT depth is 20 meter and water table is far below this depth, so there is no need for dilatancy correction. So the corrected n value is 22. Okay, that is here it is written, that is correction for dilatancy means for fine sand and silt below the water table. If the water table is not coming our SPT depth, the dilatancy correction is not needed. Okay, so that is about corrections on SPT. Okay. So for calculating the correction, first we have to do overburden correction, and after overburden correction we will be getting the n value as n dash, and on this n dash we are doing the dilatancy correction. So these two equations you should be by hearted. Okay, thank you.